Hello everyone, and welcome back to another episode of Brain Food. Do you want to live more conveniently? I know that I do. Today, we're going to be discussing how you can leverage the power of internet-connected devices in order to live a more convenient life and add a personal, creative touch to your living space. In this first video of this series on the Internet of Things, we're going to be discussing what exactly is the Internet of Things. And then we'll be overviewing an ambitious project I will be taking on over the coming weeks. If you want to skip to a specific section in this video, links will be provided in the description below. We will first start with an introduction to the Internet of Things, also known as IoT. So what exactly is the Internet of Things? Well, according to Google, it's the interconnection via the internet of computing devices embedded in everyday objects, enabling them to send and receive data. Now, let's take a look what this might look like in the modern day home. Here's a diagram of some of the most common IoT devices found in a smart home. Some of these devices include smart dishwashers, microwaves, refrigerators, fans, lights, vacuums, TVs, stereo systems, locks, and much more. Now you may be wondering how Internet of Things devices communicate with one another. Devices connected to the internet communicate with one another through what's called protocols. Protocols are simply a set of rules or procedures that are used for transmitting data between electronic devices. Listed below are a variety of protocols used by many different layers within the OSI model. The link below can provide further information about each of these specific protocols. On the left of this next slide are a few mediums through which devices can communicate with one another. Today we're going to be focusing on Wi-Fi, just because it has a very high data rate, a short range for devices within the home, and most consumer devices utilize Wi-Fi in order to control them. To the right are some of the OSI model layers that we'll be discussing in the next slide. The OSI model stands for Open Systems Interconnection Model. Currently, we're most interested in the first 4 layers of this model because these layers will be referenced in later videos. Now, let's review some of these layers. The physical layer is exactly how it sounds. It's the wires and hardware needed to connect you to the internet. The data link layer is slightly more abstract. This layer is important because it provides physical entities with the means by which to communicate with one another across the network. The network layer built on top of the data link and physical layers is the third layer of the OSI model. This layer is most notably responsible for the routing of information through computer networks and the transfer of data in the form of packets. The last layer that we'll be reviewing today is the transport layer. Transport layer is primarily responsible for facilitating end-to-end communication over a network. It is also responsible for the management of error correction, providing quality and reliability to an end user. TCP, the Transmission Control Protocol, is one of the main protocols used on the internet that lives within the transport layer. Now I'd like to introduce the MQTT protocol. The MQTT protocol is a simple publish and subscribe system that allows Internet of Things devices to pass messages through the network to different endpoints. As described by the MQTT.org website, MQTT is a machine-to-machine Internet of Things connectivity protocol. This protocol requires 2 members in order to function. The first member is a client and the second is a broker. A client is a member that subscribes and publishes messages through the broker to other clients. The broker facilitates the subscription and publishing of messages as well as the routing of messages to other clients that are subscribed to certain channels. This provides a powerful communication network because it allows different devices to subscribe to different channels and communicate with one another as well as centrally controlling units. Because clients are able to receive messages, they are then able to interpret those messages and use them as commands. An advantage of this protocol is that it is so lightweight. It requires very little bandwidth in order to send and receive messages. Additionally, MQTT clients are so lightweight that they're able to run on a variety of different IoT devices that do not have a lot of CPU power. The broker's job, which is slightly more difficult, requires more CPU power. However, this function can be run by any other more powerful device that sits on the network and facilitates the communication of the different smaller devices. Now, let's get on to the fun part, the project. The project that I want to take on over the next few weeks is a DIY smart home/dorm. Here on this next slide, we see a plan of the smart home that I want to develop. All of the things in orange are different devices that I want to install in my room. The really terribly drawn diagram is a diagram of my dorm room at the University of South Carolina. At the top of the diagram, you see a small orange line. This represents a small device that's going to be run by an ESP8266 node MCU that is going to control a motor in order to open my shades. On the left, there is a diagram of two different devices. One is a monitor and the other is a Raspberry Pi that is equipped with a camera as well as a directional network card. The camera on the Raspberry Pi will be used with a facial recognition piece of software that I wrote in Python in order to recognize who enters the room and at what time exactly they enter the room. It also may be used in a future project in order to detect people as well as where they move in the room. The monitor positioned right below the Raspberry Pi will be used in order to display a control panel. This control panel will display a variety of things that are pertinent to the smart home. This includes the lock status, who entered the room and at what time, the blind status, as well as the probe requests that are received and monitored via the network card on the Raspberry Pi. Finally, at the bottom of the diagram is another ESP8266 node MCU module. This module will use a motor control board in order to control a NEMA 17 motor to run a gear mechanism to unlock the door. All of the logistics for each part of this project are not yet fleshed out. As I begin to tackle each of the engineering challenges, I'll make videos in order to go over the solutions and problems that I run into. Let's now go over some of the components that I'll use in order to make my smart home. First is the Raspberry Pi. The Raspberry Pi will be the control unit for the whole smart home. Next is an ESP8266 node MCU Wi-Fi connected module. This module will interface with a motor control board that'll control a NEMA 17 motor that runs a gear mechanism in order to unlock the door, as well as a gear mechanism that will be used to open the blinds on my window. The next component needed is a CSI Raspberry Pi camera. This camera will be used in order to recognize faces within my room. It will also hopefully be used in a future project to detect whether my room is occupied and where people move in the room. Finally, we have the monitor. This monitor will have an HDMI port in order to interface with the Raspberry Pi. Let's now overview some of the software that will be used to control the smart home. Within the Raspberry Pi will be a web server. This web server will run the control panel. The control panel has a variety of different modules within it to control components of the smart home/smart dorm. The photo to the right is a quick mock-up that I made of the control panel. Finally, we have the monitor that will display this control panel in live time within my room, as well as a phone that represents a client that may be able to connect to the Raspberry Pi, view the control panel, as well as control the devices within the smart home. This project is super ambitious and will likely take a few weeks to complete. I'm super excited to make a few more videos to talk about how each of the components comes together for this DIY smart home, and hopefully I can review some of the problems that I ran into so that it smooths out the process for those of you that want to follow along. By the end of this series, I'll hopefully have a fully functioning smart dorm, and you will be able to follow along in order to make your own too. If you have any questions, put them in the comments below, and if you like the content and want to see more, please subscribe.